So this question is dealing with mole and more specifically mole ratio with chemical formulas. So the question says, this is 2.48 from our textbook, refer to the periodic table and calculate the molecular weights for the following compounds. So the molecular weights, I'm just going to write molecular weights of BF3 and H2S. Okay, then determine how many grams, so number of grams of BF3, okay, contain the same number of molecules, as you have 0.34 grams of H2S. Okay, so the first thing that we want to do, and again, so we're going to calculate the molecular weights of BF3 and H2S. And so with this, this one is pretty simple to do because down here, I'm not going to actually do the calculation, but using your periodic table, you would take bromine and fluoride, fluorine and, boron and fluorine, and actually calculate the molecular weight of those, as well as hydrogen and sulfur, so hydrogen sulfide there. So BF3 has a molecular weight of 67.8 grams, okay, more specifically grams per mole, and hydrogen sulfide, H2S, has a molecular weight of 34.1 grams per mole. Okay, so so we have to keep in mind that as we say grams per mole here, that it takes 67.8 grams to equal 1 mole of BF3. Okay, same with it takes 34.1 grams to equal 1 mole of H2S. So now what we're going to do is, because the question is asking for, okay, well, number of grams, how many number of grams does it take of BFF to equal the number of molecules, okay? So the first thing that we're going to focus on is solving, well, how many molecules is in 0.34 grams of H2S? So what we actually are going to do here is we're going to take the 0.34 grams given to us, okay, and we're actually going to multiply that, so that's H2S, we're going to multiply that by Avogadro's number, 6.202 times 10 to the 23, okay, over 34.1 grams, okay. The reason why we're doing this is, what we're saying is, as we talked about before, that 34.1 grams is equal to 1 mole, but 1 mole is equal to 6.02 times 10 to the 23 particles or molecules. Okay, so what we've done with this is create what is called, this was called a unit fraction. Okay, where the 0.34 comes in is the fact that, well, we don't have 34.1 grams of this sample. It would take 34.1 grams to have a total of 6.02 times 10 to the 23 molecules, but we don't actually have that. So that's why we're going to multiply that number by 0.34. So when we multiply 0.34 by Avogadro's number, times 0.34, we get 2.0468 times 10 to the 23. We're going to divide that by 34.1. Okay, and we actually get about 6.00, or 6.0 times 10 to the 21 molecules. Okay, so what we've calculated thus far is we're saying that in a 0.34 gram sample of H2S, we will have 6.0 times 10 to the 21 molecules. So now that we have determined how many molecules is in that 0.34 of H2S, we're going to now go back and determine, well, how many grams, that number of grams that we need of BF3 to equal the number of molecules that we just came up with, okay? And that number of molecules that we just came up with was 6.0 times 10 to the 21, okay? So what we're going to do now is we're actually going to take 6.0 times 10 to the 21, okay? And this time what we're going to do is we're going to multiply it by another unit fraction, and this time we're going to use the unit fraction related to the BF3. So we determined that the molar mass, okay, is 67.8 grams, okay? And what we talked about earlier is that is how much you need of BF3 to equal 1 mole. And of course, 1 mole is equal to Avogadro's number. Okay? So what we're going to do is we're going to take the 67.8 grams, and we're actually going to divide it this time by Avogadro's number. The reason why we're doing it this time and we're flipping it is because this is molecules, okay, as a unit fraction, as is the Avogadro's number. Okay, molecules, atoms, particles, we're all talking about the same thing. So because the question is wanting you to answer, well, how many grams of this substance do you need? We want the molecules to cancel out. And that's why the unit fraction is set up accordingly that way. So when we multiply 6 times 10 to the 21 by 67, 67.8 to be exact, we get 4.068 times 10 to the 23, and we're going to divide that by Avogadro's number so that we are going to be left with grams. Okay. And what we actually get when we divide all of this together is we actually get 0.68 grams of BF3. Okay, so I hope that this explanation helps. So what we have done first is we first determined the molecular weight of BF3 and H2S. And so from there, BF3 weighing 67.8 grams, what we're saying is that it takes 67.8 grams to equal 1 mole. Okay, with H2S, it wasn't, we actually were able to determine that H2S was 34.1 grams. So the first thing that we wanted to do was, because the question said, well, how many grams of BF3 would it take to have this number of molecules given that you have 0.34 grams of H2S? So the first thing that you have to figure out is, well, I don't have 34 grams of H2S, or it would just be, the answer would be 6.02 times 10 to the 23 molecules, which is Avogadro's number. We have 0.34, so a hundredth of that sample. So this is why we're going to take 0.34 grams and we multiply it by Avogadro's number and divide it by what Avogadro's number, which is 1 mole, equals in terms of H2S, which is 34.1 grams. You need 34.1 grams in order to have 1 mole. 1 mole is equal to 6.02 times 10 to the 23. So this is what, when we multiply this out, we actually will determine, well, how many molecules do we have in 0.34 grams of an H2S sample, which is 6.0 times 10 to the 21 molecules. Okay, so now what we're going to do is we're going to take that 6.0 times 10 to the 21 molecules, and this time we're multiplying by the molecular mass of BF3, which is 67.8. Okay, and again, we're using as a unit fraction here, which is saying that it takes 67.8 grams to create 1 mole of BF3, and 1 mole is 6.02 times 10 to the 23. Why we're not saying 67.8 grams over 1 mole is that we originally calculated the number of molecules present in the H2S sample, which when we only have 0.34 grams. So this is why keeping your units in a calculation can be very, very important. So the molecules will cancel out, leaving us with the grams as we see present over here. Okay, so once we've multiplied 6.0 times 10 to the 21 by 67.8, we get 4.068 times 10 to the 23. Okay, and then we have division of 6.02 times 10 to the 23, which is Avogadro's number. So that's how we're left with grams, because the molecule aspect will cancel out as a unit, and then you're left with grams as the only unit, which is what the final answer the question wants as an answer. So your final answer would be 0.68 grams.